Okay, now that we've talked about systems of linear equations in two variables, we're going to move on and talk about systems of linear equations in three variables. So let's go ahead and start this by filling this in. The solutions to an equation of three variables is called an ordered pair. So when it's with two variables, it's an ordered pair. When it's three variables, it's an ordered triple. All right, so it looks something like this, where x is first, then y, and then z. Okay, so let's look at this next one. We're trying to figure out, is 2, -1, 3 a solution for this system that's given below? To check that, we need to substitute in 2 in place of x, -1 in place of y, and 3 in place of z. And we need to do that to all three equations. And it needs to come up with a true statement for all three. So let's start with the first one. So we got x plus y plus z. So I've got 2 minus 1 plus 3. And we're trying to see, does that equal 4? All right, well, 2 minus 1 is 1. And then 1 plus 3 is 4. So 4 equals 4, so that one checks out. So that's good. But we can't stop there. We need to also check equation 2 and 3. So I'm just going to label them like this so we know which equations I'm talking about. All right, so now I'm going to have 2. In place of x, I'm going to put 2 minus 2 times -1, because that's my y, and then minus 3, which is my z. Trying to figure out, does that equal 3? So here, my multiplication, 4 plus 2 minus 3 equals 3. And then if I combine these together, 6 minus 3 is 3. So 3 equals 3. That one's also true. So it's looking pretty good, but we got to check the last one here. So now I've got -4 times 2. And then plus y, so that's just going to be -1, plus 2 times z, which is 3. Does that equal -3? All right, well, here I got -8 minus 1 plus 6. Does that equal -3? So here I get -9 plus 6. And that is -3. So I get -3 equals 3. And so that one checks out. So that means yes, all right, this is a solution to the system. Because all three of them checked out. If there was one of them that didn't check out, like say we ended up with like 0 equals 3 or something like that on that second one, then that wouldn't be true, and then that means the whole system wouldn't. This is not a solution for that system, but these worked out, so that is what we got there. All right, so moving on, I'm going to just kind of go through some steps about how to do this with the three equations, three variables. So you first want to make sure that they're all set up in standard form, meaning all of your variables are on one side, and then you have just that constant term, just a number there on the other side. Okay, you might want to clear any decimals or fractions to make it easier for you next. After you do that, you want to eliminate a variable. Let's see if I let me spell that right. Eliminate a variable using two original equations. So we're looking at like there's 3 original equations. We're going to use 2 of them. We're going to eliminate one variable. And then we're going to eliminate the same variable. So I'm going to underline same. This is super important. It has to be the same variable. If you eliminate z the first time, you got to eliminate z again. Okay? If you don't do that, you're going to be all confused. All right, and then use the 2 new equations to again eliminate a second variable. All right, then to solve for our third variable, we know what two of the variables are, so we need to just substitute in. And then you'll do that by going back to one of the original equations and substitute those in to solve for that last one. And then it's a good idea to check your answer and then state your solution as an ordered triple. Okay, so we can kind of refer back to these if you are kind of confused about the steps. And maybe the steps aren't making quite sense yet, but when we start working through them, I think you'll see what I mean about the elimination process. And here's just a good way to organize it. When we work through these problems, this first few are going to be set up in a way that is, easy for us to organize the information. Okay, so first starting out, right, I've got three equations, three variables, and so I know my answer needs to be an ordered triple. So I need to find x, y, and z. All right, and so I'm going to name this equation 1, equation 2, and equation 3. Whoops, that kind of went out there a ways. All right, so now, looking at this, it's giving us a clue here to eliminate y first. So if I'm looking at my equations here, I'm trying to think, how could I eliminate y? So let's take our first two equations. So equation 1 and equation 2. Let's look at those. Just write these down right underneath each other. It's nice to have those variables all lined up. All right, so I'm trying to think, how could I eliminate the y's? Because that's the one it's giving me a hint here to eliminate. So on this one, let's think about what we could multiply that first equation by. So I'm trying to get the y's to eliminate. So that means since I have a negative 2y, in the second equation, I want to be able to make this a positive 2y, and it's a negative y. So if I multiply it, the whole thing, by negative 2, because I can't just multiply that 1, I have to multiply everything by that same number to keep it balanced. And so when I do that, I'm just going to write that underneath here. I get negative 6x and plus 2y, and then minus 2z, equals negative 8. And now I'm going to add these together, and we can see right off that we are going to have the y's eliminated. And I was trying to make that happen. Right? So I used equation 1 and equation 2 to eliminate y. And then we'll add it together to see what we have remaining. So when I add these together, I get negative 5x. Add the z's together, I get negative 1z, or just z, negative z, and then equals 8. Okay. All right, so then I'm going to call this, let's see, I forgot to put that. I think I said negative 8, but I didn't write it. I looked back up here. Negative 2 times 4 is negative 8. Okay, so now I'm going to call this new equation, equation 4, and we'll come back to it in a minute. Now I want to go back to the original 3 and choose two other equations, and again I've got to eliminate y the second time. So maybe this time I'm going to use equation 2 and equation 3. So let's look at those and trying to eliminate there. So I have x minus 2y plus z equals 0. And then equation 3, x minus y minus 2z equals negative 7. And notice how I put those lines through my z's, because my 2's and z's look a lot alike. If yours do too, I recommend you do something like that. So again, remember, we eliminated y the first time, so we've got to eliminate y again. And it's so tempting because people look at those x's and they're like, oh, it looks easy to get rid of those x's, but you can't do that. If you eliminated x's first, then sure, then you could do that. But this one, we've got to eliminate those y's. So again, on this, kind of like we did before, we got to think about, what do I need to multiply this equation by so that when I add the y's together, they'll zero out, they'll eliminate. And so I need to multiply it by a -2. Right? -2y, or -2 times -y gives me +2y. When I add it to -2y, that zeroes out. Okay, so let's distribute that through then. I've got -2x, and then plus 2y, and then plus 4z. Right, I got a negative times a negative, so that gives me a positive, and then positive 14. I multiply it by a -2. All right, and now I'm just going to put a little line through this so I don't try and add that with it, because I changed that equation to this one in green here. And now let's add those together and see what we come up with. Okay, so when I do that, I've got -x. My y's are gone. I made them eliminate. And then my z is plus 5z equals 14. All right, and now I'm going to call that equation 5. All right, so we still haven't found one of the variables yet. All right, we're getting there, but now what we need to do is we need to put equation 4 and 5 together to be able to eliminate one of the other variables. Okay, so here, let's see, let's go ahead and put these together, and then we're gonna, I'll just put this 5 underneath here. So I just have them underneath each other. So I've got -x plus 5z equals 14. So I'm going to choose this time to multiply my equation. Let's see, I'm going to try and get rid of my x's, or sorry, my y, or my z's here. So I'm going to multiply this by 5. Right? So when I do that, let's write that underneath here, -25x, and then minus 5z, and then equals -40. All right, so now we're getting closer here. I can see that those z's are going to eliminate out. All right, and then when I add my x's together, all right, I see I get -26x. And when I subtract those, I get a -26. 14 minus 40, -26. So now if I divide both sides by -26, I get x equals 1. All right, woohoo! Finally found, one of the part of that ordered triple. All right, and then from here, it goes a lot faster. Okay? Sometimes people get to that point and they're like, oh my gosh, do we have to do that for everything? But no, now we can use some substitution to help us figure this out. So we know that x equals 1. So I want to go back to equation 4 or equation 5 and substitute that in. And equation 5 looks a little lonely over here, but I guess, we could organize it down here. All right. So what we used is equation 4 and 5, right, to find some of the other variables there. So when I do that, so let's plug that in. So I'm going to put just 1 in place of my x. So I get -1 plus 5z equals 14. And then I'm going to add the 1 over, and I get 5z equals 15. And if I divide both sides by 5, I get z equals 3. All right, so I found that. All right, so I know z equals 3 now. So there's another part of my solution. Let's go back up here and write that in. So I know z is 3. All right, so all we have left to solve is y. And we need to go back up to one of these original 3 equations. And we're going to plug x and z in there so that we can solve for y. So I would pick the one that looks easiest to you. Or sometimes people are just like, oh, I'll just choose the top equation, right? So if I do that, let's write this down here. So I'm going to just use the first equation, which said 3x minus y plus z equals 4. Right? And so the things that I found that x was 1, so 3 times 1. I don't know what y is, that's what I'm trying to solve for. And then I found that z equals 3, so I'll plug that in here, plus 3 equals 4. All right, so I got 3 minus y plus 3 equals 4. Let's combine our like terms there. I've got 6 minus y equals 4. Let's subtract that 6 over. Got negative y equals negative 2. Divide both sides by negative 1. I get y equals 2. So there is the last part of my ordered triple on this. So I get the answer 1, 2, 3. Right? And so that's what you're going to do on all of these. So again, just to talk about what we did, right? We took two equations. We eliminated one of the variables. We eliminated y. Then we took two other equations. We eliminated y again. And then we put 4 and 5 together so that we could find one of our answers, which was that x equals 1. And then once I knew that, I could plug that x equals 1 back into either 4 or 5. I can't plug it up into the original 3 because there's 3 variables there. And so if I plugged x in up to one of those 3, I'd still have 2 variables to solve for. All right, so that's why we have to go to equation 4 or equation 5. And then once I know those 2, I can plug it back into one of the original equations to solve for that last variable. Okay, let's do one more here. Probably do just a couple more on this just to make sure you really have down how to solve these systems of equations. All right, so again, on this one, I'm going to label it equation 1, equation 2, and equation 3. And then again, on this one, it's giving us a hint to eliminate z. Now, this is just a hint. You don't have to eliminate z. You could choose to eliminate the x's or the y's, but it's just looking like z might be the easiest to eliminate. So that's why it's saying this. Okay, so let's go ahead and take equation 1 and equation 2 and eliminate z. All right, so let's write those 2 down. Okay, and I'm trying to eliminate z. So let's take this top equation, that equation 1, and let's multiply equation 1 just by a negative 1. Because again, I'm trying to eliminate those z's. So when I do that, I get negative 2x plus 3y minus z equals negative 1. All right, and then when I combine those together, you can see, all right, my z's were eliminated. That's what I was trying to do. And then let's add together what we have left there on this. So I've got negative x plus 5y equals negative 2. All right, now I made a new equation. Let's call that equation equation 4. All right, and then we're going to go back up to the original 3 and pick 2 others and eliminate that same variable. And I'm trying to really emphasize that because if people make mistakes on that, it's usually that. If you eliminated z the first time around, you got to eliminate z again. So let's look at equation 2 and equation 3. All right, and see how we can eliminate z there. So I'll write these down. All right, so I'm trying to eliminate the z's. So if I multiply that top equation by a -3, and I add those z's together, do you see those will eliminate? Okay, but if I multiply one of them by -3, I've got to multiply everything. So when I do that, I got -3x minus 6y, and then minus 3z equals +3. All right. And again, we can see we have our z's eliminated, which is what we were trying to do. And then when we add the rest of them together, look at what else happens here. It's kind of interesting. Our x is also eliminated out. We weren't expecting that to happen, but it's kind of a bonus that it did. So we're just left with y here. So let's combine those together. Get -7y equals 7. All right, and I only have one variable there, so I can just solve for y. Makes it so much faster. So y equals -1. So I found part of my answer. Y is -1. All right, so now I can take that y equals -1, and I'm going to put it in equation 4 here. I don't really have an equation 5 because 2 of those variables eliminated. So let's go ahead and just put it in here. All right. And so then when I do that, I've got -x plus 5 times -1 equals -2. All right, and then now I need to add the 5 over. So I got -x equals 3. And when I divide by -1 on this, I'll see I get x equals -3. Okay, so there's the second part. So let's put that up here. All right, so now we have answers to 2 of them. So now I can just plug it back up into one of the original. And again, choose which one looks easiest to you. And I mean, I'm just going to choose to use that first equation, but you can use whichever one you want. You'll get the same answer on that. So let me write this down here. All right, and put in what we know. So x is -3, so 2 times -3 minus 3 times y, which is -1, plus z equals 1. So -6 plus 3 plus z equals 1. Combine those together. -3 plus z equals 1. And now let's add the 3 over. So when I do that, I get z equals 4. And that is the last part of my answer. Okay, and remember, you can always check these answers, right? This is x, this is y, this is z. And just like we did on that first one up here, right, where we substituted that in. So if you get an answer, all right, you can substitute it back into equation 1, 2, and 3 and make sure that it works out. If it doesn't, then maybe you made a little arithmetic mistake somewhere. So go back and check your work. All right. Okay, so let's look at problem 5. I'm going to skip 4, but you can go ahead and work on that one yourself to give you a little bit of practice. But let's work through problem 5 together. Now on problem 5, you see that there's variables that are missing on here. And so sometimes it's better to make sure that you have your x's lined up, your y's lined up, and your z's lined up. So I'm just going to rewrite these. Not doing anything to it, but just rewriting them. All right, so I've got x plus y plus, and I'm going to put 0z. To help me remember there is no z's there. If you want to just leave it blank, you could leave it blank instead. On this one, x, and there's no y, so plus 0y plus z equals 1. And then the last one stays just like it is because it has all 3 variables. All right, so now looking at this, we want to decide which one looks like it might be the easiest to eliminate. All right, so maybe on this one, I'm thinking, okay, what if I try to eliminate I can see here, I already have a z, like a 0z on that first equation, and I just have a z and a z on the second and third equation. So I'm going to choose to use equation 2 and equation 3 and combine those together to eliminate the x, the z. Okay, so I'll just write it here what I'm doing. So I'm going to eliminate z, and let me just write these underneath here. All right, so to make these eliminate, I need to multiply one of the equations by a -1. So I'm just going to take that top one, multiply it by a -1, and write my results down here. So -x, and then when I have a, 1 time or 0 times anything, it's just going to be 0. So that still stays as a 0y. Then minus z, and then -1 times 1 is -1. Okay, combine these together. The z's are gone. I made that happen. And then when I add the x's together, I get x plus y equals 0. Okay. All right, so that's kind of interesting. So this is kind of like my equation 4 here. All right, but let's go back up to the first 3 equations. And let's look and see, is there one that just has an x and a y in it? All right, and that would be equation 1. Just has an x and a y in it. So really, we don't have to do any work here. That equation 1 kind of becomes our equation 5 without doing any work. All right, we're just bringing that down. And then when I put equation 4 and 5 together, hopefully you're noticing, oh, those are exactly the same thing. All right, but let's keep going with what we've done before. What if I take that top one and multiply it by a -1 to get rid of my x's? So I've got -x. Whoops, I didn't mean to put that line there. All right, so underneath here, -x minus y equals 0. And then I see, oh, well, yeah, I was trying to eliminate my x's, but my y is also eliminated. And so then I end up with just 0 on the left side, and 0 plus 0 is 0. All right, so I end up with this weird answer of 0 equals 0, but that is not your answer. So hopefully you remember back when we did the 2 equations, 2 variables, when we had something like this, we ended up eliminating all the variables, and we ended up with a true statement here. All right, so this is true. So that means our answer is going to be infinite solutions. Okay, or all real numbers, something like that. There's infinite solutions on this. Okay. All right, and that would be your answer. Now, if it came up to be an untrue statement, so say we ended up something like with 0 equals -1, all right, and so that's a false statement, and so if something like that happens, then that is a no solution, like we talked about in the previous, in the 2x2 systems. Okay. All right, so I am going to leave that here. Remember, there are little things that you can kind of do, by yourself. I know, you might not be able to have, other people to work with, but if you do know some of the people in class, it would be a good idea to do some of these little activities there. Okay. All right, and also do these warm-ups. These warm-ups would be things that might help you kind of refresh your mind on what we talked about in the previous module or earlier things. And those could be really helpful for the exams, right? So try and remember to do those warm-ups. Just test yourself on those. All right. I hope that was helpful for you.